Record. Sweet. So let's record. So again, we want to only make public facing as much stuff as people will want to use for this linked list. And so we said we have some properties. There's a head, there's a tail, there's a count, there is property is empty. So our properties, what is head going to be?
A node.
Yep, head is a node. Which node is it?
The first one?
Yep, very first node. But here's the thing. If someone makes a new linked list, they don't want anything in it, right? And so we might just say var head is a linked list node, type T, question mark. Sorry. It's an optional node because then this starts nil, so there's no first node. So we create an empty list by default. That's why it's been optional every time we've made a linked list, is because when someone goes and creates our new list is linked list, let's say of type ints for now, they can do this and get back a linked list that has nothing in it. And I'm actually going to leave that there because if we set this up, we shouldn't see, if we set this up correctly, we shouldn't see any errors for this line 35. So if we define our linked list correctly, we shouldn't see errors on the line below because we should be able to, or better put, because our definition should allow us to make an empty list. So even though we're going to have all these properties, those properties need to be set up in such a way that we don't need an init function. Cool. So what is the tail? The tail is a node. Which node is it?
The last node.
Yep. So Tia, I'm setting up the tail. How should I do this?
Same as the head, LL node, make it a type 3. Optional. No, wait. Yeah.
So similarly, why is the start optional? Tia, stay with me.
I'm thinking because if there is no node, there may not be no, if there's not a linked list, like if linked list is nil, then there may not be a tail. Sorry.
So our node is different than the linked list. The list is empty, but we also want tail to be nil so that it doesn't have to start out with a value. So when we initialize an empty linked list, we should return nil when we go looking for the tail because there actually isn't anything there.
Okay, that sounds good.
Eric, is that your daughter?
Yes.
I love it. Nima, what is this count property?
It's going to be of type int. I'm guessing it's just to count the, maybe like the number of nodes in our linked list. What is it actually for?
Yeah. Count is an int telling us how many nodes are in the linked list. So let's say I've got var count. It's an int. This is one of the steps where it's gonna say, hey, you need to initialize it with a value. How can we account for that though? I don't want to make it optional because I want count to always exist. So I don't want to ever get back a nil value for count. But kind of just thinking about a data structure holding objects, when I initialize a linked list, what should the count be? How many nodes should there be in it?
At least one. So can you say one?
Well, remember, I want this line to continue to work without an error, but I also don't want to have to initialize my list with anything in it. So what's the count if I initialize it without anything in it?
If
0.
Yep. So we'll just say when we define a linked list that our count is 0. That's it. Then in each of our functions, we'll have to make sure we are tracking addition or subtraction from count. All right. Here is a fun one. Jocelyn, can I ask you to help me with this? Is_empty is going to be a bool. How do we get the value for this bool?
Oh,
Sorry?
sorry. I don't remember. Hold on.
Okay.
How do we do that?
So how do we know when our linked list is empty?
Oh, when it's nil.
When what is nil?
The head.
Cool. So all we want to do is return head equal to nil. So if head is nil, then our linked list is empty. If not, our linked list is not empty. Just remember, is empty is seeing that there is nothing in here. So it's not like, is there stuff? It's the opposite. It's the absence of stuff.
If you're returning head if you're returning head is equal to nil though, that's the Boolean that we're returning?
Yep.
Okay. Is that true or is that false? Got it. All right.
Yeah, we're kind of like asking the opposite question of what you would think. We'll typically use this and say, if not is empty, do stuff. Yay, bools. All right, how do we feel so far? Let's add some instance methods. One is going to be append value. Does this change the linked list?
What do you mean by that?
Like, is it going to change my list, or am I still going to have a nil head, a nil tail, 0 count, and an is empty that returns the thing?
It's going to change your list.
Yeah. Mutate our list. What about remove all nodes with value? Is that going to mutate our list? Cool. And then what about reversed? I'll highlight the important part there. Is this a mutating function?
Yes.
Let's see how we defined reversed. Reversed returns a linked list with its nodes in the opposite order of the original list.
Oh, so you want the function to return a list?
Yep. So this
Uh,
list does not mutate it. This is sort of similar to the sorted, whereas something like sort is. Think about the naming conventions here.
Question, but the head is going to be different than the tail when it's reversed. So isn't that different?
So this is going to return that. So if I did something like new list dot reversed, that's going to return a value here. So let's say, I don't want to do the function signature just yet. That's going to return a value, which means like I want to do something with that value, which means reversed list would need to be a way for us to store that value. It doesn't do anything to new list, but if I said, all right, I made a list, I did some stuff, and then now I want the reversed list. Now I have a function that can just provide me that reversed list without changing new lists.
Now I hear it. Go ahead, Soraya. Tell me about the best.
Yeah, I'm sorry how silly this question is, but there are no indexes in linked lists.
So that's not a silly question, it's a great question. We can't index them with we can't do like new list like that by default. But we could totally set it up so that there's a function called, ooh, this is a great stretch. Stretch, set up subscript. So there's actually a built-in keyword subscript that allows you to set up, just similarly to like other syntactic shorthands, you can set up a subscript that you define. So think of it as like, I'm sorry if this ruins the magic, but in the same way that double equals is actually defined, what's inside of those square brackets when you're looking for an index or when you're looking for a key in a dictionary, that's defined. Like it goes and it looks for that. You're just using a shorthand. So you can definitely set up a subscript so that you can define to look for indexes. And let's say if head equals, or if linked list at 0 equal to the head. So by default, no, we don't have indexes. If you wanted though, it's something you could definitely implement. But I think we'll see with our second mutating function that setting up indexes on our linked list is going to be kind of tough, or keeping track of them at least is tough because, hey, here's a problem. Things move around all the time. So let's use our linked list like a linked list right now. Let's set up some stuff for it. Let's start with the function append. Does this append of any return value?
no.
Cool.
It needs to, right? It needs to mutate the linked list, so it needs to.
Well, mutating and returning are different. What is mutating? I think that's a great point of clarification. Mutating is changing this instance. Returning is creating a different instance. So append is going to add something to this list, which means that this has to be mutating. We don't need to return anything for append. We just want to say, okay, go add this there. Think of it like an array. How can I append something to this list?
We're inserting a new node with a value at the tail.
Mm-hmm. So we got to make a node, right? I said, add the number 6 to our linked list. Well, those 6s, those ints get stored in nodes. So let's make a new node. Let node equal linked list node, value, and what's this argument going to be?
T.
So the type is t, but the argument that we use to create this is just the value that we got as a parameter in this function.
I knew that.
Cool. So we make a node. And then let's talk about it in words. First, append is to the end. So this node will always become the tail. But what else do we need to do?
Check if there's a head.
Yep, go ahead. What else do we need to do?
We need to know where the tail is as well, so we can move beyond it.
Make sure the tail right now is attached to this new node. So if our current chain is
You know what? I can tell you guys were just the tally of kids last year. She is
2,
on it.
3, 4, and I want to add 5, I can't just say 5 is the tail, because it's not linked to the other nodes yet. What should I do first?
We're going to review the 7 elements of art. Now, you might recognize some of these right away, but some of these you might not have. You might
Okay. Question, the way that linked list works, you can't just jump to any kind of tail. You'd have to start at the beginning and cycle all the way through, right? Because only the information of the head only has the next over.
That's correct. So, and that's the important point here is, if I went looking for something in my linked list starting at head, but I'm only adding to the end, I need to make sure that 4 is attached to 5 so that I can get from what's currently the tail to the new tail I want to create. So anytime I'm adding to the end, I want to say that the tail.next is equal to this node. The nice thing is, we then say tail is equal to the node. Here's a very swifty thing. What happens if tail is nil right now?
It becomes the head.
All the way back to pre-K, right?
So
And
we're going to have to
Or,
You know
Go ahead.
sorry,
colors, you know
I'm mixed up. You said if the tail is nil?
Mhm.
If tail is nil, then there's nothing in the linked list at all, right?
Right.
So then whatever we're appending needs to be the head and the tail.
Cool. And why is this line 51 okay?
I'm really confused by line 52, honestly.
We'll get there.
So Ryan, go ahead. What's the difference between shade?
So line 51, let's say tail is nil. Why is there no error here?
This is optional.
So we're using optional chaining,
Perfect. I better myself. Shades are
and it will just stop doing anything. So if this tail is nil, then tail.next is also nil. And so it doesn't worry about whether there's a value or not, but if we go to use it,
in your picture.
we'll just get back nil.
Artist, when you have your
Tail is nil, tails next is nil, and assigning some property to nil just isn't going to do anything at all. That's why we're using optional chaining.
who can guess or who knows what texture is?
Okay.
Joshua, you need to put one A into the
So what we
text
did here is
column.
first step,
Who knows what texture is?
4 from here to the 5.
Go ahead, Autumn.
And then the next step is we want to make sure in the future, when we're looking for tail, we should be looking at 5. This is how we add to the end. First, we make sure that the end that currently exists is going to be attached to the node we're looking at. Then we say, okay, but in the future, if anyone wants to see tail, so let's say I want to append again right after this. If anyone wants to see tail, I got to make sure it's referring to the very last element, which is the thing we're adding now. So first we draw the link, we connect them, and then we reassign the value of tail to be our new node. So our new node gets connected to the last node of the list, and then it gets named as the last node, the tail.
Can I try to rephrase what you just said?
Please.
Hold on, honey, because we're.
Line 52 is kind of like the arrow in the diagrams that we're seeing.
Mhm.
It's making that occur, right? And then line 55 is actually putting that number there.
So it already exists, and all we're doing is remember that this is a linked list now. It's not a node. A linked list is meant to be like the way that we keep all of these, we keep track of all these objects. A linked list has a tail, and we just want to be able to say, hey, later on, if you want to look at new list.tail, it should be the one that we just created. It's not going to do that automatically because tail is still assigned to be whatever it was before. So we're just reassigning it. Tail is just looking at an object, and we're just saying, hey, when you look for that object, make sure you're looking for 5, not 4. So if we don't reassign it, it doesn't change that. Let me ask, for any linked list, what should tail.next be?
No.
Yep. So maybe that's another way of thinking about this. We're enforcing the rule that tail is always the last node. The last node always points to nil, so its next is always nil. So right now at 52, that's no longer true. Tail.next should be nil. It's not, it points to something. That something is this node. Another way we could write this is literally tail is equal to tail.next. because we said tail.next is this node. 55 and 56 are saying the same thing. Okie doke. All right. So we've added things to the end. There's some other things we want to do though. What if there's no head?
I'm gonna look at a series of pictures
You want to make
of artwork by
that new node the head.
Yep.
Do you also make that new node the tail as well?
Yep. So in the case where there's only one node, that node is both the head and the tail.
We have to wrap this stuff in if statements, right? Because we're not doing all of this at the same time.
Oh man, I need logic. If head is nil, thank you, Tia. So if head is nil, head is now this node. But just to note, every time we go to append, we're adding it to the end. So every time we make our new node the tail. Sweet. And then what other properties should we update as well?
The count?
You say count plus equals 1. We've added one more thing. So let's see if this works. New list dot append 3 print new list dot tail print new list dot count new list dot append 4 print list dot head dot value print list dot tail dot value and print new list dot count. What do we expect these things to all be equal to? What's the value going to be here?
3.
What's the value here?
1.
What is head's value here?
3.
Head is 3. But what is tail's value now?
4.
Sweet. And lastly, how many nodes are there? What's the count?
2.
Cool. Let's see if it works. How'd we do? Seems good to me. Of course, these are optionals because tail is an optional node. So we'd have to unwrap it to use it. That's okay. All right. Actually going on a little longer than expected. Let's do the rest tomorrow morning. So if you haven't worked on them already, work on these two. We're returning a reversed linked list, so not mutating this one, and removing all nodes with a specific value. Let's stop there for now.